then you guys are going to be forced to listen to me for the whole evening, and so be it. Okay, well, last week we started talking about lighting. I was trying to give you some background information so you can better understand some of the facts and figures and information that you see in relationship to lighting products. So we will continue on with that. I was going through and looking at some information and comparing various lighting sources. So just a reminder, we talked about incandescent lighting and basically looking at a couple different pieces of information. First of all, being the color temperature, whether you perceive that light source as being warm or cool, the lifetime or mean life of that particular lighting source, and its lighting output in lumens and energy input in watts, and putting that lumens and watts together, dividing lumens by watts, we get a measure of the efficacy or the relative efficiency of the lighting source. So we can use that to compare one light source to another. So again, this is what things look like for incandescent. We started talking about halogen lighting being similar to incandescent in many ways, right? We're passing an electric current through a filament, and that filament is glowing. The difference in a halogen lamp is that inside the glass envelope, there's a halogen gas, iodine or bromine or something like that, that fills that little quartz tube, and that helps with the lifetime, to extend the lifetime of the halogen lamp, right? So halogen lamps come in, just like everything else, come in different shapes and sizes, right? A lot of us might see, if we have can lights in our house, let me turn the finger on here. If we have can lights in our house, we might see a small fixture like this or this in our can light. If we have a sconce or a shop light, we might see a halogen bulb that looks kind of like that in there. Again, for halogen, it's more compact, right? The bulbs are a lot smaller. There are certain fixture types that halogens work very well in. Lifetime's a little better. Some of the cons, that bulb operates at a high temperature. It's pretty hot. You can't touch it. You typically have to put some kind of shielding around that lamp to keep you from touching it. And still, its efficiency or its efficacy is relatively low. But halogens are good applications if we have something like a track light or a can light, something that's an intense point source, or a spotlight, a work light, a wall sconce. These are all things that are good applications for halogens. So again, just like the incandescence we saw, we can also look at the characteristics of the halogen, same information, color, temperature, lifetime. In this case, the efficacy is pretty poor, right? It's actually slightly lower in this case than what that incandescent was. Here's another example, right? This tubular 75 watt halogen. Again, similar to something you might have in your shop light, or in our house. My wife has this halogen, has a fixture, a sconce fixture behind her desk that has this this T3 lamp in it. Good evening, Leland. Thanks for joining. We're just getting started talking about comparison of various lighting sources. Right, next thing to talk about is fluorescent. So fluorescent is going to operate differently than the incandescent or the halogen. So in this case, we're passing a current through an ionized gas that's inside a tube or a container, so we're not heating up a filament. We are causing gases to ionize by passing a current through them. Fluorescent lights typically have long life and high efficacy or high efficiency. No worries, Leon. Thanks for joining. Glad you made it here. The difference of a fluorescent is the fluorescent needs a transformer or a ballast to regulate the voltage that is passed between the filaments in that fluorescent lamp. So fluorescent typically has a tube and a ballast in some form or another. Right, so here's a linear fluorescent, right? You quite likely could have something like this. If we were sitting in Triton, we would look up at the ceiling and we'd see light fixtures that have this sort of lamp in them. I think at Triton we can't actually see the lamps, but in a lot of commercial office space or classroom buildings, you'll see a light bulb that looks like this, a long tube with a double set of pins at each end of the tube. And again, we are passing a current through a gas, and that gas causes, or the ionization that gas causes, the coating on the inside of the tube to glow, producing the light output. We also have this type of fluorescent lamp. It's called a compact fluorescent. In this case, the bulb and the ballast is built into one unit. These were fairly common. This is what we were replacing incandescents with for a long time, and now this technology has largely been supplanted by LEDs. Again, along with the tube itself, a fluorescent fixture typically has a ballast. So again, if you have a fluorescent fixture like this in your garage or in your shop or your basement, and you take the cover off, you're going to see this small cased transformer that's taking the line voltage and providing the current that's necessary to ionize that gas in the tube. And just like incandescents, the linear fluorescents come in a variety of different shapes and sizes. Most of them, or many of them, are tubular or T. T12s would be what was a fairly common light for a long time. Now, in all likelihood, that's been replaced by a T8. So again, that number 8 is in eighths of an inch. So a T8 linear fluorescent lamp has a 1-inch diameter. So again, if we were sitting in the classroom at Triton, we would look up and we would in all likelihood see 4-foot T8 fluorescent lamps in the fixtures over our heads. I think that's what you see in the library at Triton and probably lots of the other rooms at Triton. So again, what are some of the pros and cons? Fluorescent light has a much substantially longer lifetime than these other light sources, much higher efficiency or efficacy. Generally has cooler temperatures, right? So it'll be a higher number of Kelvin degrees, right? 3,500 or 4,100 Kelvin. So we generally aren't going to use these fluorescent light sources in our living spaces, in our dining rooms or living room or something like that. But we certainly could have it in our basement or our shop or our garage. Generally speaking, fluorescent isn't dimmable. The other downside of fluorescent is that it contains mercury, right? Mercury is a hazardous material. So we have to be careful about the what happens to our fluorescent lamp if it breaks, and how that fluorescent lamp is disposed of. So again, good applications for linear fluorescence, obviously a classroom or an office, long on time, long burn hours. We don't need to dim. Those cooler color temperatures are acceptable, right? Those are good places for fluorescence. Here's our compact fluorescent. Let me go back to the chat. Sorry about that. I saw someone's chat come up. Weird purplish flashing when they go bad. That's a good question. I'll have to think about that, Max. Let me think about that, and I'll answer you at the break. Good question. You have these spiral or compact fluorescents, Max, or do you have the long linear ones? Okay, got it. We're talking. So the other way that we can see fluorescent lights are these screw-ins or compacts. Again, this has the tube and the ballast kind of built in. Right, in this case, these were improvements over the incandescents. They were meant to be a replacement to a typical 60-watt A16 incandescent. You know, this technology, these were pretty dreadful when they first came on the market, but you know, they got a lot better now. They've largely been supplanted by LEDs. But again, we see the same warm white color temperature, a fairly decent color rendering index, or CRI, long life, good efficacy, right? Here's the downside. We see the little, if you remember your periodic table from high school science, right? Hg is mercury. So in our fluorescent light says contains mercury. So be careful about how you dispose of it. Right, generally speaking, because that fluorescent light contains mercury, mercury is a hazardous material, we shouldn't be throwing our lamps into the regular trash. We should be taking them someplace that will accept those fluorescent light bulbs. So some of the home improvement stores accept them, some of them don't. Right? I'm always a little disappointed by Menards, right? They're going to sell you a fluorescent light, but they won't accept the, they won't take back one that's burnt out. It's been a while since I've checked on this list here. I was just at the Home Depot the other day. I should have looked and see if they were still accepting fluorescent lights. But the point is that this is something you should not be throwing out of the garbage. You should be taking it someplace that accepts fluorescent lamps for disposal because of that hazardous material, because of that mercury that's in the lamp. So one thing that we are trying to do is provide a little more guidance to consumers about the hazardous substances that sometimes can be found in their consumer products. So the RoHS, or reduction of hazardous substance, is something that is in use in Europe. You might see some products for sale in the United States that have this RoHS compliant symbol. But when you see it, it means that we're trying to drastically reduce the amount of some of these hazardous materials that are in our consumer products, right? Things that we shouldn't have and cause us problems in terms of health impacts or disposal, right? Lead or mercury or cadmium. So again, we just talked about mercury in fluorescent lighting products. So the technology, the most up-to-date lighting technology is LED, or light emitting diode, or solid state lighting. Right, so here we're using a solid state diode that we pass current through and it glows. It's a semiconductor, right? Think of it as a a semiconductor, just like the photovoltaic cells that Tyler talked about in his presentation a couple weeks ago. Those LEDs, generally speaking, produce a single color, and an individual chip gives you one color. So basically, the designers of these products have to mix chips that produce different colors together to get the white light that we expect to see in our lighting products. So again, down at the chip level, we have something like this. Right, we have a piece of silicon or some material, solid state material, that's going to glow when we pass a current through it. And then we have to put a lens on it and put a backing on it, and we have to have some way of dissipating the heat that little device produces. So again, LEDs, this is the current best available lighting technology. Obviously the pros: long lifetime, high efficacy, there's no mercury in that LED. I'm sure there's probably something else in there, but I don't know what it is. Right, I was reading in the paper today about some of the materials that we're going to need to put into our EV batteries, and where they're coming from. Countries, and I think the country was the Congo in Africa, where there's conflict over sources of cobalt that we need for EV batteries. So anyways, no mercury in the LED. Some of the cons, and I should probably update this. It's been a couple of years since I've worked on this presentation. They were more expensive, but that prices have come down rapidly over the last couple of years. So again, when I went to the Home Depot the other day to buy some new light bulbs, pretty much everything there was an LED, right? It's the LEDs have displaced incandescence and compact fluorescence for the most part. So I could pick up, still a couple dollars a light bulb, but that's far less expensive than they were even a couple of years ago. Rapidly evolving product choices. I would say that quality has gotten much better. Again, I need to update my slides here. I think now we're pretty comfortable that when you buy a light bulb like this, it's going to actually perform and last the way that it's slated to. You have to be careful when you're buying a LED light bulb. If you're putting it in a fixture that you want to dim, you need to make sure that you're buying a dimmable product. It doesn't always dim the same way that an incandescent does, right? As you dim an incandescent, the color temperature gets warmer and warmer. Some LEDs do that now and some don't, so it doesn't always appear the same way that an incandescent does when you dim it. And it's a little harder for us to get the warm temperatures, so it's a little less efficient. Generally, the cooler LEDs are more efficient. But this is the direction that lighting technology is going in, right? This is what we're going to be doing. This is how we're going to be, reducing energy consumption for lighting products. Right, again, so when you go to the hardware store, you're going to see 60-watt LED replacements for a typical incandescent. They're going to look something like this. Looks a lot like conventional, or looks a lot like the incandescent bulb that we're used to seeing. Right, we see the color temperature is warm white. The CRI, or the color rendering index, is pretty good, pretty long lifetime. And that efficacy right? 89 lumens a watt, so substantially better than the incandescent that we started with a couple of slides ago, right? So we're moving in the direction of providing the same amount of service, right? The same light output, the same illumination with a light source that's 5 or 6 times more efficient than what we started with. So that's moving in the right direction. Certainly moving in the direction of reducing energy consumption and reducing carbon in our lighting. So again, the lighting products, when you go to the home improvement store, you're going to see some label like this that will give you that information we just talked about: the color temperature, the color rendering index, the watts, which is a input, right? How much energy input is required, what's the output, what's the useful work that that light is providing, and what's the lumens per watt, or the efficacy. So again, information that the manufacturers give to us as consumers to allow us to make good decisions about the products that we're going to buy. Right? Also, lumen maintenance. This has to do with how much that light dims over time. So over time, the output of the bulb will tend to diminish, but it still has a fairly long lifetime. And warranty information, I know, these products all carry some sort of warranty, but, for me, God only knows, 3 or 4, I buy a light bulb and I put it someplace and then it burns out a couple of years later, and, I can't remember where the hell I bought it from. So, the warranty on something like this is pretty hard to deal with. Okay, I forgot what that link was, so we'll go right past that. When I went to the store yesterday, there was a whole display. Philips, which is one of the manufacturers of lighting products, had a whole display of these smart LEDs. So in essence, you can have a bunch of light bulbs in your house that are all Wi-Fi enabled, and you can control them from your smartphone or whatever app that they're going to give you. So theoretically, now you can turn your lights on and off, or dim your lights, or change the color of your lighting of your lights if they have these smart Wi-Fi enabled LEDs. I've never tried this technology, so I can't say one way or another whether it works or not, but it sounds kind of interesting, and maybe some of you who are younger and more tech savvy will try some of this stuff. But again, this seems to be coming on the market more and more. Again, I saw a whole display of it at the Home Depot the other day. So this is one component of the smartphone. Yeah, Mac, what does your friend say? I mean, I'm again, maybe I'm old-fashioned. We had an Alexa for a while, and I thought the Alexa was a little creepy, since it was listening to, even if I never said the magic word Alexa was always listening to me. So finally, my wife and I unplugged the Alexa and stuck it in a drawer or something. So, but yeah, I mean, I think this stuff is pretty cool. We'll have to see how it pans out. But this is the direction that technology is moving in. Right, so why are these changes happening? Well, these changes are happening that, technology is moving along. People are discovering things and finding better ways of building better products. We're getting more functionality, more features at a lower cost, right? That's happening in lighting, that's happening with our smartphones and our computers and everything else, right? So well, that's pretty cool. Yeah, that was my understanding as well, Mac. I'm just reading Mac's chat here, that yeah, you can dim them, turn them up and down, change the color temperature. So again, I think, I think I mentioned I finally broke down and got a new iPhone, right? I think I went from my iPhone 5 to an iPhone 12. So, I'm kind of sort of getting with the program here. So again, we have manufacturers that are responding to demands of the marketplace for higher performance, better products. In this case, it's helping us move in the right direction in terms of reducing our energy consumption, reducing our carbon footprint. And oh, by the way, we've got lots of cool features now, right? We can dim lights, we can change their color temperature, and they're more efficient. So that's all cool stuff. We have utility incentive programs that help drive some of this change. And certainly we have the government moving us along as well. I think we talked about utility incentives a while ago, right? In some cases, you're paying money on your gas or electric bill to support efficiency programs. And the way you might see that is, some cases the utilities are still providing, point of sale or incentives in the store. I didn't actually see anything when I was at the Home Depot the other day. It's been a while since I bought light bulbs. In the past, I would always see their, the little comment thing pointing at a display and said, "Hey, we took $3 or $2 off of the price," but I didn't see that anymore. So maybe they don't do that. But so again, the utilities might still be providing incentives and certainly providing information to us as consumers to help us know what the correct or most efficient lighting products are to buy. This EISA, or Energy Independence and Security Act, passed, 2007, right? That seems like a while ago now. But this was something that the government did to essentially help move us away from some of these less efficient lighting sources, right? Basically setting efficiency standards for various kinds of light bulbs. Again, trying to push the marketplace in the direction of developing higher performance, better quality, more efficient lighting products. But eventually these conventional incandescents will be rendered obsolete by EISA. But like anything with the government, right, things tend to come and go depending on which party is in power. I think when I did this slide a couple of years ago, I think the Republicans were trying to slow down some of these lighting standards because they thought that, the government shouldn't be telling people what kind of light bulbs to buy. I thought that was kind of, I don't know, it sounded like a Republican thing to do. I mean, in my mind, this is helping drive the marketplace and helping to encourage us all to be more efficient, to reduce our CO2 and our carbon footprint, right? I thought it was doing things and moving us in the right direction. So the lighting products that I talked about, excuse me a second. Sorry. Was talking about what might be typical in a home. Let's touch briefly on the sorts of things that we would see in commercial space, right? So in a store or an office building or a Triton classroom, right? We're quite often going to have our linear fluorescent light fixture, and it's going to be in what's called a troffer, right? So this is a fixture that's going to sit inside a ceiling grid, a T-bar ceiling grid 2x2 or 2x4 lighting fixture, and have a variety of shapes and sizes and types of lenses. So again, if we were sitting in the classroom at Triton, I would point up and say, here's a X, Y, or Z lighting fixture. I can't remember what's in the classroom in our building, but I believe it's one of these direct indirect fixtures like that. But again, behind that shield, there are some linear fluorescent lamps. So again, these are the light fixtures in one way or another that are going to be typical in commercial interior space. Or you might also have pendant mounted fixtures like this. The fixtures will, point some light up and bounce it off the ceiling and point some light down. So this would be part of a design or an engineered lighting system to provide higher quality lighting for the folks sitting in this office here, working on their computers. Going along with our light fixtures, we quite often have lighting controls. I can't remember if I pointed these out when we walked through the H building way back when, early in the semester, but I know in the H building and many of the rooms at Triton have these occupancy controls, these motion sensors. Through various means, they're going to sense when someone is in the space and turn the lights on or off. Nowadays, the building codes are steering us in the direction of manual on and auto off. So they actually want us to come in and push the button here to turn the lights on, and then the lights will time off or turn off when no occupancy is detected. So again, building codes are moving us in the direction of having lighting controls such as this, right? We want to have the lights on when there are folks in the space, and lights go off when nobody's home. Another lighting control that we might see in a commercial space would be what's called daylight sensor or daylight harvesting. Right, in this case, we have the lights in the space dimming in response to the amount of sunlight or daylight coming into the space. Right, so this would be done in conjunction, hopefully, with other design elements to produce what's called a daylight harvesting system. So, the orientation of the building, the location of the windows, where the windows are located, all kind of work together such that we can have natural light providing some of the illumination instead of it coming from artificial light sources. So the lights would dim in response to the availability of natural light to illuminate the space. So again, this is technology that's becoming fairly common, right? Still relatively new, but becoming more common. Okay, so that's the inside lighting in a typical commercial building. So let's talk a little bit about what is outside, what's illuminating the parking lots or the exterior, right? Generally, we'll have two different types of technology for commercial exterior lighting. We might have HID or high intensity discharge. This would be a HID typically has a lamp and a ballast. And we might have either metal halide, that's going to be kind of the bluish light, fairly common, or the yellowish light that we still see in a lot of the street lights, certainly in the city of Chicago, that's high pressure sodium. So again, these are various different mixtures of gases in a tube, and that gas glows with electricity from a ballast. And now we have the same LEDs we saw as individual lamps inside our homes are now becoming much more common in commercial exterior lighting, right? So at Triton, we have LED lights, all those pole fixtures in the parking lots at Triton are LED, and what's around the campus is probably a mix of LED and metal halide. But again, we're moving to LED because of its efficiency and longer life. Right, so what are some of the different types of fixtures we might have in a commercial exterior lighting system? You know, we might have wall packs like this, you know, mounted to the side of the wall, in this case, illuminating a parking lot or a sidewalk along the side of a building. Or floodlights, right, in this case, attached to the side of a building and shining out to illuminate a parking lot, hopefully not being too objectionable or glary. Here's our pole lights. Right, again, this is what we have throughout the parking lots at Triton. Remember when we were at Cernan, right, first or second week of the semester, we saw the presentation, Losing the Dark. I talked about dark sky, about the impact of artificial light on our health and the life of wildlife, life of the creatures around us, you know, the ability of astronomers to do their work. Right, we talked about some issues related to lighting, light pollution being one of them, simple steps that we can do to mitigate it. Right, remember one of the things that the movie talked about was dark sky compliant lighting fixtures. Right, so we have those at you know, one of the things that makes the H building certified, we have them at Triton. Right, we have the fixtures designed to direct the light downward and have less light going upward, less waste up into the sky, more light down, less waste up, you know, less energy for the same amount of illumination. Right, so this is a good, well-designed lighting fixture. So when we're out as lighting designers or architects shopping for or specifying exterior lighting products, nowadays you're going to be looking at the bug rating on that fixture. In this case, bug stands for backlight, uplight, and glare. Right, we're trying to make sure that you know, the light from that fixture goes where we want it. Right, we don't want the light necessarily to go backwards or up. We don't want it to be glary. Right, we want to put the right amount of light where we need it and not be spilling light, you know, on places where that light doesn't belong. So again, this light fixtures with this sort of rating, along with good lighting design, will give us the sort of results that the folks who made that movie were hoping that we would do. Right, what are we trying to eliminate? We're trying to eliminate light trespass. Right, we don't want the light from our property or our light fixture to be lighting up adjacent properties or adjacent sites. Right, if you have your house next to a Taco Bell or a McDonald's or something, right, you don't want all the light from the drive-in at the Taco Bell lighting up your backyard, right? That's light trespass. You know, we don't want that to happen. We want to make sure that we minimize the amount of uplight to the extent that we can, keep our skies darker, reduce that artificial sky glow. We want to try to reduce glare, right? We don't want people driving around in their cars to be distracted or annoyed by poorly designed lighting systems. Here again is our model codes. Remember our I codes, IRC, International Residential Code, IBC, International Building Code, IECC, International Energy Conservation Code. Again, these are model codes that municipalities will adopt. So the IEC, the model code, you know, has some stipulations related to the efficiency of residential lighting systems. Not less than 75% of the lamps in permanently installed lighting fixtures shall be high efficiency, right? So they're telling you that, at least the building code is pointing you in the direction of higher performance lighting fixtures. In commercial lighting design, I make the point here, lighting is an engineered system, right? As you as an architect, if you're doing a commercial project, if you're good and thoughtful, you do the lighting design yourself, but you might turn to your electrical engineer or a lighting designer to design the lighting system for you. And there are, just like there are in many professions, there are professional handbooks, guidebooks that provide the guidance to do this sort of design. So in this case, we're going to start with an analysis of, what are the uses of that particular space, what work is done in that area, what tasks are being performed, and how much illumination is actually required to do that task, right? Whether it's reading or office work or classroom or brain surgery, whatever it might be, right? The IES handbook will stipulate offices should be designed around so many foot candles of lighting. Also, the energy codes that apply to commercial spaces, again, will have stipulations for the amount of energy that can be used for lighting. Quite often they will have what's called a lighting power density. So the code will ultimately say this is how many watts of lighting you can have installed per square foot of space. So again, getting back to LEED, since that we're talking about here in the BD&C, or building design and construction LEED standard, there's going to be things related to lighting in sustainable sites, right? There'll be a credit for light pollution reduction, right? So applying that bug rating we just saw a few minutes ago, right? That'll help you point you in the LEED rating system will point you in the direction of thoughtfully applying good high quality lighting design. Obviously in energy and atmosphere, as we'll see later today or next week, a lot of points available for optimized energy performance in BD&C, right? The largest single category of lighting. And we'll talk before the end of the semester about credit category IEQ, or indoor environmental quality. In that case, we're looking at both control and quality of indoor lighting. Again, in EBOM or operations and maintenance, right? Again, BD&C is design and construction of new or major renovations. O&M is operations of existing buildings, right? We'll have some of the same things will apply: light pollution reduction, energy performance. We also have in the M&R, materials and resources category, we'll be looking at the getting that mercury out of the lamps. And again, the same things related to interior lighting, quality of lighting, and control of lighting. Okay, some takeaways here, and remarkably, I'm just about on schedule here for break time. So just to wrap up, we talked about a couple things. We talked about lumens, which is a measure of lighting output, watts, which is a measure of energy input. Putting those two things together, we have LPW, lumens per watt, or efficacy, right? That's a measure of the performance of a lighting source. So LPW, more is better, more output for the same amount of input is moving us in the right direction. Color temperature and color rendering index, or CRI, Those have to do with the appearance of the lighting sources. Color temperature is how warm or cool we perceive the light to be. And CRI is how accurately that light source renders coloration. So again, CRI may not necessarily be that important to us in most applications, but let's say you're designing a retail store or you're selling jewelry or something like that where you really want people to see exactly your merchandise, then you're going to be paying attention to CRI. Talked about different types of lighting sources: incandescent, halogen, fluorescence, compact fluorescence, and LEDs or light emitting diodes, and the lighting facts or consumer information that we have available to us to help us make good choices about what we buy, and hopefully driving us in the direction of buying better, more efficient light sources. Any questions? Okay, well, why don't I stop the recording here